So the last part of National Free Geography we're going to look at is a global issue. And there is one global issue that's kind of been dominating the headlines. And probably will continue to dominate the headlines for the next couple of years. And that is global climate change. So our climate is changing and we are experiencing the backlash of that. So have a look at this diagram. It kind of shows we're in 2020 now, which has been a bit of a rubbish year, but we know exactly what the kind of world was looking like, and then who knows what it's going to like in the future if we don't change something and don't try and slow down or stop climate change. So, first of all, what is climate change? Because it's got about various different names depending on who you listen to. So climate change is the large-scale, long-term shift in the planet's weather patterns and average temperatures. So day to day the weather might change, particularly in Scotland. It can be snowing in the morning, sunny in the afternoon and raining in the evening. That is not climate change, that is just changing weather pattern. Climate change is large-scale, so over the course of entire continents, countries, long-term, so you're talking about hundreds of years, changing the kind of planet's weather patterns and average temperatures. And from the kind of mid-1800s, humans have contributed to climate change by the release of carbon dioxide and other greenhouse gases into the air. And this is hugely important later on. So, why is global climate change important? Why do we need to understand about our atmosphere? I'm going to put myself back up in a second, but we want to look at the importance of the atmosphere and what it does for us. So, our planet, or our planet that we're aware of, is the only one in our solar system which is able to support life because of the temperature, because of the availability of water, because of the atmosphere protecting us from dangerous radiation. Right? Basically, the atmosphere keeps us warm enough, so if we compare ourselves to Mars, our atmosphere keeps us at about 14 degrees Celsius. Mars doesn't have an atmosphere. You can't breathe in it, there's no oxygen, and the average temperature of Mars is minus 55 degrees Celsius. So hugely disparaging and different kind of temperatures based around our atmosphere. So the reason we are so warm at 14 degrees Celsius is the greenhouse effect. So what happens is sunlight passes through the Earth's atmosphere, the radiation. It comes in the form for us as heat, which is pretty good, particularly in the summer, and it passes through the Earth's radiation. Now, a third of it is reflected by the clouds. Some is reflected by the clouds back into space, away from us. It doesn't affect us, it doesn't hit us, it doesn't heat us up. All right. And what happens is heat hits the Earth's surface, it heats up the Earth's surface, making us slightly warmer. This happens more around the equator and less at the North and South Pole. And what happens is it would then be radiated away into space and we'd maintain a nice warm kind of 14 degrees. What's happening is the air, the heat and radiation that's trying to leave, these arrows here, actually gets stopped by the greenhouse gases and end up getting sent back to Earth a second time, heating us up again. So as the radiation is trying to leave, it's getting trapped by the greenhouse gases, it's hitting the greenhouse gases and it's getting reflected back to Earth, making us much warmer. So the more these greenhouse gases are in an atmosphere, the more that's happening and the warmer we are getting. So one thing we need to be able to do with climate change is we need to be able to take data and back up our point. So what we've got is we've got two graphs here. We've got this pie chart from 1995 and this pie chart from 2035. And what this is showing is it's showing us the amount of emissions from each country or region of the world in 1995 compared to 2035. So here is how we structure it. We structure it as in the date, and we take the earliest date, so 1995, country or area name, and let's use the USA. So in 1995, the USA was responsible for, and we look at the graph and we say 22% of emissions. So in 1995, the USA was responsible for 22% of emissions, compared to and we'll go for the number in the new date compared to 15% in 2035. So that first sentence is, in 1995, the USA is responsible for 22% of emissions compared to 15% in 2035. This is a difference of the high number, 22, take away the low number, 15. What's your answer? 7%. Alright, so that's how it would look there. In 1985, the US was responsible for 22% of emissions compared to 15% in 2035. This is a difference of 7%. Now it's really important that we take the dates, the area, or whatever it's talking about, the high number, and then compare it to the low number with the dates. So if you don't have the dates in, they can't kind of easily compare. And then we know the difference by taking the high number away from the low number. So what I want you to do is have a look at the graphs in your OneNote, use the structure provided, and I want you to compare parts of the graphs and the tables that have been provided for you. As always, if you've got any questions, stick them in the posts part of our teams and someone will be able to help you out and answer them for you.